Hello everyone, my name is Entezari. I am going to present our paper for 26th International Conference on Fracture and Structural Integrity touring Italy. The topic of our paper is on the assessment of non-metallic inclusions by Part 13 of API 579 one ASME Fitness for Service 1 2016. The first author of this paper is Professor George Luis Gonzàlez-Velazquez, and I am corresponding author. The authors are from Department of Metallurgy and Materials, Instituto Politécnico Nacional, Mexico City, Mexico. Our paper contains six parts: introduction, theoretical overview, scope and assessment criteria of non-metallic inclusion by Part 13 of API standard, fitness for service assessment of zones of non-metallic inclusions, fitness for service assessment of inclusion zones by Part 13 of API standard, result and discussion, and finally conclusions. The presence of non-metallic inclusions in the pressure vessels made of low carbon steel exposed shore environment is one of the main factors to increase the susceptibility of hydrogen cracking or HIC. The zone of non-metallic inclusions are considered as a lamination, and fitness for service assessment is done by methodology similar to those of lamination. This table shows the research background of authors worked on the effect of non-metallic inclusions on remaining life of pressure vessels. In this case, Gonzalez-Velasquez claimed that interface between the non-metallic inclusion and the steel matrix is the preferred site for hydrogen therapy. And Lu and Dang also claim that the HIC crack are commonly associated with cluster of silicium, aluminum, manganese, and calcium based on non-metallic inclusion in steel plates. Hank, Kim, and Rehman indicated that large inclusions are prone to trap more hydrogen that increase HIC susceptibility, and they concluded that the shape, size, separation between non-metallic inclusions could be considered as a critical factor for HIC propagation. Gomera and Sudakov claim that zones of closely spaced non-metallic inclusion in pressure vessels are considered as laminations, and Gonzalez-Velasquez also reported that laminations may be interconnected by plastic deformation and be close enough that create a large damage area. Part 2 Theoretical Overview. The non-metallic inclusions are not considered as a defect by code standard. These standards consider them as a lamination for assessment purpose by structural integrity. In this case, according to paragraph 13, dot 4.2.1 of API part 13, the level 1 assessment procedure of lamination in a type A component subjected to internal pressure is summarized in 10 steps. Step 1 is obtaining the significant dimension of lamination. The significant dimension in longitudinal and circumferential direction. And step 2 is verifying this criteria, and LS is the distance between lamination, and TC is corroded thickness. And if this criteria is satisfied, the Dimensions of a lamination can be measured by this figure, and all laminations can be considered as a single lamination. However, if this equation is not satisfied, uh, the dimension of lamination have to be measured separately, like this figure. Step 3 is verifying this criteria, and LMSD is the distance between lamination and other structural discontinuity. And these criteria is as a function of external diameter of pressure vessel and corroded thickness. And if this equation is satisfied, we can go to step 4 to investigate on lamination height. And if the lamination height is equal or less than this equation and this value, this and this, we can go to step 5 to determine corroded thickness. The corroded thickness is as a function of wall thickness of pressure vessel and future corrosion allowance. Step 6 is verifying this criteria where the minimum measured thickness or TMM have to be greater or equal this value. And if this criteria is satisfied, we can go to step 7 to investigate on the distance between lamination and weld joint or weld metal. And if this equation is accepted, we can go to step 8 to study on these criteria. And in this criteria, the dimension of laminations have to be less than or equal this value. Step 9, if the conditions of step 3 to step 7 are met, the lamination is acceptable by level 1 assessment and no corrective action is required. Otherwise, the component is rejected and the level 2 assessment is recommended. Step 10 and the final step is determining the reduced maximum allowable working pressure. And it is worth mentioning that if the lamination height criterion of step 4 is not satisfied, the lamination is evaluated as a crack-like fellow using level 2 methodology of part 9 API standard, where the crack depth equal to the lamination height. In this study, the authors have followed two goals. Goal 1 is level 1 and level 2 assessment of pressure vessels by API standard, and goal 2 is adopt the conservative fitness for service assessment procedure and criteria procedure in Part 13 of API standard. And finally, we received bright results mentioned in the next slide in this presentation. This slide shows the photograph of assisted pressure results, this image, along with pressure result designs indicating the identification tag. And we found the non-metallic inclusion zones in the heat and the cylindrical section of these pressure vessels. And here in this area, here in this area, and this area, and this area, we found the non-metallic inclusion zones. And also, this table contains technical data of pressure vessels indicating the type of component and the type of component. This, as you can see in this image is cylindrical horizontal to spherical heat welded, and other important data like maximum allowable working pressure, external diameter, nominal thickness, and minimum thickness and future corrosion allowance. And these data help us during fitness for service assessment of this assisted pressure vessel. Here in this slide, you can see the nature of non-metallic inclusion zones of the pressure vessels, assisted pressure vessels. And you can see here closely spaced non-metallic inclusion zones, and we can consider them as a laminations. And also here you can see two examples of detected zones of non-metallic zones detected by Pound screen records, and one is close to weld joint. This non-metallic inclusion zone, as you can see, this zone is so close to the weld joint, and another is isolated. These non-metallic inclusion zones. This table shows the dimensions of inclusion zones and parameter cited in previous slides. Please remember this value. Please remember this value for these non-metallic inclusion zones because this zone is so near the weld metal, as I said in previous slide, and LW is the important parameter that have an effect on the procedure of fitness for service assessment. This table shows the summary of level 1 and level 2 assessment, and as you can see, the LW, or the distance between laminations and weld metal, and also LMSD, uh, or the distance between non-metallic inclusion zones and other structural integrity, and the lamination height and the criteria, uh, dimension criteria, has been rejected for non-metallic inclusion zones, and this causes the level 1 assessment has been rejected. And in this case, the level 2 assessment was done by means of commercial fracture mechanics software by data obtained from mechanical properties of a static pressure vessel that is cited in this rectangle. In this case, we considered the defects and or lamination as a crack-like fellow, where the crack tips equal to the lamination height, and crack length is the maximum value of the lamination dimensions. And by calculating chi R and LR, we found that all assessment points were into the failure assessment diagram, and also the maximum allowable working pressure, reduced maximum allowable working pressure, that was calculated by the Annex C of API standard. We found that this parameter, maximum allowable working pressure, is much higher than the design maximum allowable working pressure, which is cited in table 1 of this presentation. And furthermore, LW, this parameter has a direct effect on remaining life of these inclusion zones. And this inclusion zones has a lower remaining strength factor because the LW, or the distance between this area uh, and the well metal, is so close. However, the level 2 assessment has been accepted for all non-metallic inclusion zones. Results and discussion. The level 1 assessment was done in this research and was rejected. And the criteria that caused rejection in all cases were lamination height, lamination size, and spacing to a major structural discontinuity, or LMSD, or LW, or the distance between non-metallic inclusion zones and weld metal. And the level 2 assessment, all five defects were acceptable, and the only defect that was more far from the origin of failure assessment diagram was this non-metallic inclusion zones that is so close to the weld joint, and this causes the remaining strength factor uh, uh, reduced. However, other zones have a remaining storage factor greater than 15, and the proximity of this non-metallic inclusion zone to weld joint was the main factor that affected and reduced the remaining storage factor. Uh, Conclusions and adopted rules in fitness for service assessment of non-metallic inclusion zones as a final chapter parts. The fitness for service assessment of tertiary research containing non-metallic inclusion zones has been accepted in level 2 assessments, and the conclusions showed that the most important dimensions for assessment are lamination size and spacing to the nearest weld joint, and the lamination height can be disregarded, and these dimension criteria can be disregarded due to fact that discontinuities and dispersed nature of non-metallic inclusion zones don't have an effect on the remaining storage, and if possible, it is advisable to skip the level 1 assessment and directly perform the level 2 assessment, since it provides less conservative assessment when the non-metallic inclusion zone is evaluated as a track-like defect. Latter would like to acknowledge the National Polytechnic Institute, IPN, National Council of Science and Technology, CONACYT, and Group of Pipeline Integrity Analysis of IPN. Thank you for your attention, and if you have a question, you can send your question to this email address. Thank you so much.